Hello and welcome to another math formula deriving video. Today what we are going to do is we are going to try to derive the formula for kinetic energy. So we know that an object will possess kinetic energy if that object is actually in motion, right? So what we mean by that is, let's say we have a object of mass m which is traveling at a velocity of v. So that means the object will have kinetic energy equal to half into mass into velocity squared. So what we are going to do is we are going to first try to find out how this formula is obtained. So in order to do that, we will first consider the work done. So what we mean by that is, in order for an object to move, we have to do some work on that object, right? That means, let's say an object is at this location here. Maybe we can call it at x1. The object is at location x1, and if we are to move that object, because kinetic energy is the energy that occurs when it is moving, right? So if we are to move that object, we would require to apply a force of F on that object. So when a force of F is applied on that object, this object will move. Maybe the new position of that object will be at x2. So that would mean we have moved that object by a distance of dx. So with that definition, the work done of an object is actually going to cause the object to move. So that is kinetic energy. The work done would be equal, the work done when the object moves is going to be kinetic energy. So if we express this in a graphical manner, so our object is at x1, we are moving it to x2 by applying a certain force. We can call it as Fx. So if that is the case, the total work done on the object would then be the integral of x1 of Fx from x1 to x2. So we can write that as work done is equal to integral of Fx dx x1 to x2. So this work done is nothing but the kinetic energy. So maybe we can write kinetic energy x1 to x2 dx. When the object moves from x1 to x2, there is a force being applied, so that force will do some work on the object, which from the energy conservation law, right? So work done would be equal to the energy that object possesses, right? So that is why kinetic energy is equal to the work done of the object, right? So with that definition there, we can say that F is nothing but ma from Newton's second law of motion. So we can rewrite this formula. So we have written force as an acceleration. So in order to integrate this, because our integral is with respect to x, which is displacement, we will consider the definition of acceleration. So acceleration of an object occurs when the object is initially moving at v1 if the object is accelerating, the velocity would change into v2, constant acceleration. That means we have a change in velocity of this object from here to here. The change in velocity is dv. So this change in velocity happens at a particular time. So maybe the time here is t1, and the time here is t2. So a change in velocity of dv occurs at a change in time of dt. So acceleration, we can define it as the change in velocity over the change in time. How much velocity is changing of the object at a given time. So with that we can say acceleration is equal to dv over dt, that is with respect to velocity and time. So now consider the displacement of the two. So at t1, let's say that our displacement of the object is at x1 and the displacement of the object at t2 is x2. So that means when the object accelerates from v1 to v2 velocities, the displacement also changes from x1 to x2. So maybe we can consider this as dx, the change in the displacement. Now I can write our formula for acceleration, a is equal to dv over dt, in terms of the displacement. So a is equal to dv over dt. We can write this dv over dx times dx over dt. That what I wanted to do is to write the formula for acceleration in terms of dx. We can see that because dx and dx can get cancelled out, so there's nothing wrong in writing acceleration as dv over dx times dx over dt. So we know that dx over dt is the change in displacement over the time. Dx over dt, are changing the displacement over a change in time. So that is nothing but it is velocity, isn't it? Change in displacement over change in time is velocity v. So now I can write my acceleration as dv over dx times velocity, which is v dv over dx. So now if you compare our earlier integral ma dx, kinetic energy, is the integral from x1 to x2 ma dx, and I have an expression for acceleration which I can substitute there, right? So substituting so we have our kinetic energy equal to integral of x1 to x2 ma dx. So let's substitute the value of acceleration there, the value that we obtained from this, integrate from x1 to x2 m v dv over dx times dx. Over here we can see that the dx and dx we can get rid of, and we have now been able to change the equation for kinetic energy to something with respect to voltage, mv dv. And since we are now dealing with velocity, velocity not voltage, right? So since we are dealing with velocity, we can change the limits to velocity as well, because at x1 the velocity is v1, and at x2 the velocity is v2. So kinetic energy, we can change the limits of the equation now, integral from v1 to v2 mv dv. We can then integrate it with respect to velocity. We can take the m out, integrate v1 to v2 v dv. Integral of v is nothing but half v squared, the limits being v1 to v2. Substitute the limits in. Kinetic energy is equal to m half v2 squared minus half v1 squared. So if the object that we considered was initially at rest, that means v1 is equal to 0, and the velocity that it currently possesses, the velocity that it's currently moving, is v2. So maybe v is equal to v2, v being the current velocity of the object. So we can say v2 is equal to v, the current velocity of the object is v. So if we make that assumption, we can say that the kinetic energy that the object currently processes, right? So over here it is the change in kinetic energy when the object moves from a velocity v1 to a velocity v2. But at the moment, the current kinetic energy that the object has is at v2. So therefore we can say kinetic energy is equal to half mv squared, because when v1 becomes 0, this quantity will get cancelled out. Right, so that is the equation or the formula that you can use to solve or obtain the kinetic energy of an object. We will see you in another video.